Our next speaker is Cagil Gumus, or CJ for short. He's an FPGA developer in the accelerator beam control group at DESY. His work focuses on development of and maintenance of large scientific instrumentation system, with particular emphasis on RF feedback and SDR application, being diagnostic and high precision timing and synchronization system. So CJ will present today the FPGA firmware framework, or FWK for short, which, citing the documentation here, it's a modular article-based framework designed to automate the creation and build process for FPGA projects using various ADA tools. So CJ, the floor is yours.
Okay, perfect. So I'm very happy to be here. Great workshop so far. So thank you for the invitation here. So I'm going to be talking about FWK. But before I tell you what FWK is, maybe I can explain who we are, because that will give a context of why we did all of this. So we are the accelerator beam control group at DESY, and just like in CERN, we have a bunch of accelerators that we play with. And our group, the FPGA group, responsible from deploying and maintaining FPGA installations throughout DESY campus and beyond the DESY campus as well. And we deal with fast feedback systems, timing, synchronization, beam diagnostics, DAQ applications. And we have about, I've looked it up a few months ago, we actually have to support something like 100 unique FPGA bit streams, and we have to maintain them. There's strict release cycles, so it's a lot of designs that we have to support. And we have this pool of more than 500,000 lines of HDL code that we really have to keep it somehow stable to support all of this. And yeah, this is our team. Actually, we recently went to the tunnel and took some of these fancy photos. By the way, if you want to be a part of our team, we recently opened up a position, so you can apply here. But if you look at the timeline of FWK, it actually started way back in 2009, even 2006, there were some hints of this framework. But we started with this SVN repository. It was closed. It was just only for us. We, using this pool of libraries and tickle scripts, we started developing these accelerators. So biggest one that we accomplished with the framework was the European XFEL. That was the biggest project that we actually succeeded. And from 2009 to 2020, there was this huge explosion of code that we had to write to do all of these things. And the repository grew exponentially, and the framework that we were using had to also get more and more feature-rich. However, during this time, we also realized that there were other facilities that were equally interested in what we were doing, whether they were maybe using the same hardware or they were using different hardware, but they needed the same application. So let's say low ref control, they wanted to do the same low ref control, but maybe in a slightly different way. So they started taking this closed proprietary stuff that we had, and they started using it. However, around 2020, so just before COVID era, we started thinking a bit more broadly, and we decided to actually just consolidate everything, and we wanted to open source everything, and such that the collaboration gets easier. So that was a big strategical decision. It was kind of a nightmare, actually, to convince all of the management to do this, but eventually they gave in, and we started converting and consolidating all of these closed source into cleaned up, refactored as an open source. And from 2020 to 2025, we started migrating this behemoth to the new what we call FWK, and we give it a name. We didn't have a proper name, and we decided to call it FWK. And from that open sourcing event onwards, there were more and more people started coming in. And just last year, we decided that the framework is now at least mature enough that we could maybe start calling it 1.0. So we released 1.0. And again, the goal here is truly that we want to increase the collaboration between the scientific institutes. And maybe more importantly, we believe that the public money equals public code. And I think this is also philosophically aligns more. And yeah, so that was our goal. So, and it's spread to many facilities. So these are the facilities that I know that used FPGA bit streams that originated from FWK. So it was also used on CERN, for example, for a Wake project. Of course, DESY, European XFEL, heavily relies on FWK-generated products. And a lot of the German accelerator research facilities started using it. So the list is growing. What's really interesting is we start having industry to also take a look at it, because funny enough, the users of these accelerator projects started demanding companies to make their example designs based on FWK. So then they kind of had to force to use FWK, which was kind of nice for us. And it also highlighted a lot of bugs, missing features. So it was also quite beneficial for us. So what is FWK? So it is Tcl-based open source FPGA framework. And the main job here is to automate the creation and build processes of EDA tools. And the heart of the FWK is actually relies on this concept, what we call a module. So, and modules, I'm going to explain more what they are, but they're essentially these encapsulated, pretty encapsulated, shareable pieces of code. We support a lot of tools, actually. So, of course, in the synthesis and implementation, we have the AMD products like Vivado and some old FPGAs we have to still support. I mean, there are some Vertex 5s we have to support. Imagine 2026. We still support ESA, Model Sim for verification, of course, GHTL and CocoTB, Vitis. So we can also do like bare metal applications using these modules as well. And interestingly, Yocto is also a part of that. So the modules can be also in the context of Yocto. So it's a bit more broader than just HDL code. It can be actually generalize this idea of this encapsulated things into something more. And the list is growing. And we wrote the framework in a way that we could extend new tools easier. So we have proper abstraction layers to allow this. So how does it work? So we start with this module. It's essentially, you can imagine it as a container for an IP. It's a Git repository, and it's the main building block of FWK. And what you do in this module is, this module can contain a lot of files to describe what you want to do with this. So it could contain, for example, a bunch of HDL source files. It could contain something about a software like C code, C++, Python. It could also contain its own documentation. And it could even be a bunch of Yocto recipes, actually, as a module. This is also possible. And all you have to do is just to write one single Tcl file to explain to the FWK what this module needs and what it needs to do in the context of project creation and build process. So we have a quite extensive documentation of this module Tcl. Essentially, what a module can do is it could show its configuration space to FWK. So it could say, here are the parameters that user can change. Some metadata it could provide. It could also, of course, it needs to point to a lot of files in the disk to say, I need this file, I need this file. And you can also do like context-aware file selection. So depending on maybe some tool set, maybe you need different files than the other. So you can kind of do all of this in the Tcl. And interestingly, we also added these standardized calls for verification and testing as well. So verification and testing is also part of the module repository itself. And of course, address space management, which is for us was kind of a big deal. We heavily rely on creating registers, which I will talk about. So you can also describe how much of an address space this module actually occupies. And of course, some versioning things, which is quite important in the context of machine deployment is very important to keep track of your versioning, and FWK is very version aware of the modules. So what's very cool about these modules is that they are stackable. So you could take a bunch of modules, and then you can create modules out of a module. So you can kind of stack them. And these Tcl scripts that you write could kind of point to each other. So you can create a very hierarchical tree. And what FWK does is it starts from the most top module and it starts going into the leaves, and it starts resolving all the configuration, and it handles the address space. So it all does, everything is in a one big waterfall loop, and at the end you start with a one major configuration. So at the top you have this one major configuration, and then it starts going into the leaves, and then your whole project is configured. So after you set up this chained modules, all you have to do is it becomes just a make command. So you could just pick the main configuration that you want. You could say, grab all these modules together and create me the project. So you could create suddenly the Vivado project, combining all of these modules. And then you could trigger the FWK to start the build process. So it will then trigger the synthesis and implementation. If it's a Vitis, it will start doing the whole build and start creating the ELF file maybe, right? And also, before maybe it's even built the module, it can also test the modules one by one to make sure that under those configurations, does it still, passes. So, which was quite important. So we, as I said, we wrote a lot of modules for our needs, of course. I've did this graph a few months ago, so it's gonna change. It's probably different numbers now, but in total we have like 108 modules, and just the 25 of them right now is open source under the CERN Open Hardware License. But we want this number to be equal, like the orange number should be the same as blue number. So we want to increase the openness of these modules as much as we can. And one of the highest number of modules that we do is actually what we call a board support package, which is, we think that this is one of the most sought out modules that people actually want, which I will explain later. And yeah, you can come visit our GitLab page to see what kind of modules available. You might find something that you're interested in, so feel free to check it out. We also have some tutorial modules to teach people how to create these modules and how to write these tickle scripts. And yeah, so BSPs is something, as I said, it's very important. So what we realized in this FWK business, that people really like abstracting hardware. Because if you can create these abstraction between the application and the hardware layer, you could then port your application to different hardware, right? You could, like, hardware upgrade becomes much more simple, and people can use the same platform to do different applications. So we essentially write these BSPs to abstract all of the hardware and present you, for example, a bunch of AXI buses. So you can represent, let's say we can take an RFSoC board, and we can abstract everything away from you and present you all of the, let's say, data as in simple buses. So then your application is now irrelevant to the what kind of board you're dealing with, which was quite important and showed a lot of value to developers. And we were mostly dealing with micro TCA hardware, but then we started writing board support packages also for the evaluation boards, and community started writing these more cheaper alternatives to be able to take our, for example, applications to port them into much more lightweight platforms and much cheaper platforms. There's also one more tool that we developed. It's called DESY RDL, and that is that most of these modules uses a lot of registers, and throughout these years of developing them, we realized that this manually creating register logic is pretty error prone. So we decided to use a standardized register description called system RDL. And then we went ahead further. We not only describe our register, but we also generate the VHDL logic necessary to realize the register logic. And we can even change the interface from AXI to something else. So it really decouples the registers from the underlying structures you do, which makes these modules a lot more portable across different platforms. And FWK and DESY RDL is pretty tightly coupled. So when you stack these modules, their address spaces can also automatically get combined, and then all of the address decoder gets automatically generated. So you don't have to write any address by hand. So it's pretty fast. Yeah, so, and the last slide is the future of FWK. I mean, actually, Francesco said something very important. So when we first started this, like the 1.0 or FWK development, There were tools, but it wasn't so stable, and of course we decided to went ahead. But now the situation is a bit different. Like the community evolved a lot. There's a lot of alternatives. So there's FuseSock, Idealize, Hog is used by CERN. There's Silicon Compiler, Pile of course. So there's a lot of tools now. And I think our strategy that we want is we would rather merge over fork. Like we don't want to draw our own destiny, but I think it's a lot more beneficial if we join forces. So I highly agree on this. But of course, because it's a huge repository, it will take us very slow. It will be a gradual process to switch everything. But of course, the same comic I use as Francesco, we don't want to end up in this more competing standards. And of course, we are committed to contribute to the open source scientific ecosystem. So, and I would like to thank you for your attention. Yeah.
Thank you for your talk. So thank you. If there are any questions from the room. I see a question there.
Hello, and thank you for the presentation. If I understood well, does FWK helps the developer to find the needed source files for each vendor in order to recreate the project from scratch?
So you have to write this. Let's call it passport, right? You have to tell FWK what this module needs, and this is a manual process. But what FWK does, you can chain them together, and FWK kind of creates the whole project for you, where every module tickle can get aggregated, and then you can kind of configure them all at the same time.
So you need to create the list, let's say, manually for HDL, constraint files, IPs.
So you have your source files, and all you have to do is essentially like point to the files to say, okay, I want these ones, and my address space is this, and then FWK processes them all. I hope that answers your question, but maybe we can talk.
Okay, yes, because we had already faced this problem, and we created, let's say, custom tickle files for a vendor that it didn't support. It wasn't very version compatible and easy to find which are the needed files. So we need to, it would be helpful for the developer to, if someone can dictate what are the needed files and save him very precious time.
Correct. Yeah, I agree. We can talk afterwards to dig more on this. Yeah. Yeah.
A thing you didn't say, or maybe I didn't get from your presentation.
Sure.
What is FWK? Do you install it? Is it compiled?
So you can imagine like a tickle script that you add it as a Git. You can add it as a Git, but we can also bring it as a Python as well. But what it does, again, it relies on the concept of modules, and it kind of scans all of the modules with a given configuration and creates you the, let's say, Vivado project.
This bit I got. What it does, I get. It's what it is. So do you install it in your system, then you go to your terminal and you go FWK this, or is it a part of your project?
It's a part of the project. So it's not like a tool that you install into your system, but it just comes with the whole, let's say.
So if I have 10 projects, I have 10 times FWK. Hog is also like this, so I'm not...
Right, yeah, that will be like that,
and
yes.
It's a module, it's an add-on to your repository that...
Correct. You have to include FWK into the same repository that builds the artifacts.
So when I clone the repository, I have everything.
You get everything, exactly. So you just check out, let's say, low-level-F project.
And
you check out and then...
Yeah. Is it you said it's tickle script. Because
yes, it's tickle-based, yeah.
Where does it run? Does it run on tickle shell?
It runs inside the tool tickle shell. So like it kind of injects itself into, let's say, Vivado, and inside the Vivado it operates, which gives us quite powerful things to interact with the tool as well.
Yeah, so we did the same thing.
Yeah, it's pretty similar to it. And that's the point here. So there's a lot of similar things that we do, but as I said, we will evaluate the alignment for 2.0, and we will try our best to maybe merge. That's the goal.
Hello. Thanks again for the presentation. Maybe I'm asking something naive, but how are you handling diamond dependencies between modules?
Yeah, very good question. So right now we don't, because we realized that it could get quite hairy, and we didn't want to write a proprietary package manager. However, as the modules numbers increases and the version changes, it's now up to the developer to figure out which module is depending on what, which is not a scalable approach. I must agree. So we will probably implement in the future a package manager such that the dependency graph can be resolved automatically by FWK. Yeah. Yeah.
Why do you need make? When you have tickle scripting and everything, why do you need make around it?
I mean, it's just one step and then the rest is tickle, but I mean...
Can't you get rid then of make and just use tickle?
I think in theory we can. We can, but yeah, I mean, decided to do make, yeah.
Okay, there was another question there.
Yeah.
If I were to integrate like some of my own cores, can it theoretically do mixed language? So could I also integrate like a system Verilog module, or does something prevent that?
So theoretically, yes and no. FWK is not specifically targeting one language. However, some features of FWK is only available on the VHDL part. So yes and no, but it's mostly VHDL centric, but there's nothing stopping you from creating modules that also maybe system Verilog. However, some of the things might maybe not work. Please come to us if you hit those problems.
Okay, I don't see any. Oh, yeah, there.
Hi, thank you for the talk. I just was wondering, how does this change how you would use Yocto? Like, would you still use bitbake, or how does it make it easier?
Yeah, so for the Yocto sense, it's a bit not tightly coupled, because one thing that we really want to do is that we want FWK to be part of the full chain, meaning that you do the, let's say, PL design, and then you bring in your PS, and then you could then encapsulate everything into a full-blown embedded Linux image. And each step of the way, we want FWK to be part, because we could then have a nice one big chain, and we can see where it fails. So in the Yocto sense, the modules, they're not necessarily, so it's still bitbake. I mean, we're not changing how Yocto is built. It's just that, so modules are mostly describing the PL. However, it's not like we changed how Yocto is done. Let's say it's still bitbake, and it still depends on the layers. But the layers can be kind of buried into the modules, and then you can bring them like that. Yeah.
Okay, great. Another question there. Yeah.
Thanks for the nice presentation. Does FWK support continuous integration, or
support what?
support continuous integration?
Yes. So the CI/CD was one of the main reasons why we wanted to integrate all of that. So the answer is yes. Yeah.
Okay, Francesco.
Yes.
So you mentioned versioning, and
yes.
And one of the reasons why we did HOG was to guarantee that nothing is touched. Does it do anything like that? Like, for example, I clone the repository, I change a file, or because how do you do the versioning?
So it doesn't necessarily track the dirty state. If you check out and if you do some fiddling, it won't be able to warn you that it is now a different, let's say, hash. It doesn't do that. So how it does is it actually is aware of the versions, and it will also propagate these versions into some known registers. So in that sense, we kind of bury the information to the logic so that software can kind of check this, but it doesn't have that features of tracking if something was edited. So yeah, that's...
So just as a recap, it seems to me that the main difference is that FWK is two things. It's a system to create the project
That's
locally,
right.
but it's also a library of VHDL that is done in a certain way to be compatible with it.
Right. So we have the FWK, which is the framework of Tickle scripts, but then we also have just like pile of cores, like just pool of stuff that we could use. But it is kind of two separate things. You're right. So the one is a framework, the other one is like bunch of IPs or modules that you could reuse. And our hope is not necessarily more. I mean, the value here is not maybe FWK, but these modules themselves, because that's what most of the people are interested, because they really want to have that abstraction and forget about the complexity and then focus on something a lot more simpler.
Yeah, then we should really.
Yeah, we definitely need to
together,
talk. Yeah, 100%. Yeah.
Okay, great. So maybe we will merge two tools together. Maybe.
Yeah, that would be amazing, actually.
Okay, great. So if there are no more questions, let's thank our speaker again.
Thank you.